Hello everyone. Welcome to the course Principles and Applications of Mechatronic Systems. Today we are going to study Chapter 5, Hydraulic and Pneumatic Control Technology, Pneumatic Transmission. The content of this lesson includes 1. Characteristics of pneumatic transmission and the composition of a system. 2. Working principle of pneumatic transmission, functions of commonly used pneumatic system components, and their graphic symbols. 3. Analysis methods for typical pneumatic systems. Pneumatic technology is an application technology that uses compressed air as a power source to drive pneumatic actuators to perform specific motion patterns. It is widely used in industrial production. Applications include packaging, feeding, metering, material conveying, workpiece rotation and flipping, classification, and various machining processes such as turning, milling, drilling, and sawing. The working principle of a pneumatic transmission system is as follows. The air compressor converts the mechanical energy output by the motor or other prime mover into the pressure energy of compressed air. Under the control of control elements, and with the cooperation of auxiliary elements, the actuator converts the pressure energy of the compressed air into mechanical energy, thereby performing linear or rotary motion and doing external work. Let's take the air shearing machine as an example. Its working principle is shown in the figure. 1. Air compressor. 2. Aftercooler. 3. Water separator and drain. 4. Air tank. 5. Air filter. 6. Pressure reducing valve. 7. Lubricator. 8. Stroke valve. 9. Pneumatic directional valve actuator. 10. Cylinder. 11. Workpiece. The air compressor produces compressed air, which passes through the aftercooler and water separator, then is stored in the air tank. From the tank, the air flows through the air filter, pressure reducing valve, and lubricator, and then through the directional control valve actuators to the cutting cylinder, 10, and feeding cylinder, 8, to cut the material. Next, let's learn the composition of pneumatic transmission system. As shown in the diagram, 1. Safety valve. 2. Air compressor. 3. Air tank. 4. Pressure reducing valve. 5 and 6. Directional control valves. 7. Flow control valve. 8 and 9. Cylinders. 10 and 11. Mufflers. 12. Lubricator. 13. Filter. As shown in the diagram, a typical pneumatic transmission system consists of 5 main parts: air supply unit, auxiliary components, control components, actuators, and compressed air. First, let's look at the power components. They convert the mechanical energy supplied by the prime mover, such as an electric motor, into the pressure energy of the gas, providing power for various pneumatic devices. Factories and mines with large air consumption generally set up a dedicated compressed air station to uniformly distribute compressed air to each point of use through pipelines. 2. Actuating elements. They can convert the pressure energy of the gas into mechanical energy, outputting force and speed, or torque and rotational speed, to drive working parts. Examples include cylinders and air motors. 3. Control components. They are used to control the pressure, flow, and flow direction of compressed air to ensure that the actuator outputs a certain force and speed. These components include pressure valves, flow control valves, directional valves, and logic elements. 4. Auxiliary elements. In addition to the above 3 types of components, auxiliary components include filters, dryers, silencers, lubricators, and pipe fittings. 5. Working medium. The main working medium is compressed air. Next, let's learn pneumatic system symbols. 1. Pneumatic power component, air compressor. As shown in the diagram, the general symbol of an air compressor, the symbol of a unidirectional fixed displacement pump, and the symbol of a unidirectional variable displacement pump. 2. Cylinders. mainly single-acting cylinders and double-acting cylinders. 3. Pressure control valves. As shown in the diagram, these mainly include A. Pressure reducing valve symbol, B. Sequence valve symbol, C. Relief valve symbol. 4. Directional control valves. As shown in the diagram, these mainly include 2-position 2-way, 2-position 3-way, 2-position 4-way, 2-position 5-way, and 3-position 4-way directional valves. 5. Flow control valves. As shown in the diagram, these mainly include non-adjustable flow valves, adjustable flow valves, exhaust throttle valves with silencers, and one-way throttle valves. Now, let's summarize the main advantages of a pneumatic transmission system. 1. Pneumatic devices have a simple structure, are lightweight, easy to install and maintain, have a low pressure level, and are therefore safe to use. 2. The working medium is air, which is inexhaustible. Exhaust handling is simple, does not pollute the environment, and is low in cost. 3. The adjustment of output force and working speed is very easy. The operating speed of cylinders is generally 50 to 500 millimeters per second, which is faster than hydraulic and electrical methods. 4. Using the compressibility of air, energy can be stored to achieve centralized air supply. It can release energy in a short time to achieve a high-speed response in intermittent motion. It can provide cushioning and strong adaptability to impact and overload. Under certain conditions, pneumatic devices can have self-protection capability. 5. Fully pneumatic control has fireproof, explosion-proof, and moisture-resisting capabilities. Compared with hydraulic systems, pneumatic systems can be used in high-temperature environments. 6. Due to low airflow loss, compressed air can be centrally supplied and transmitted over long distances. Its main disadvantages are: 1. When the cylinder runs at low speed, due to the large proportion of friction in the thrust, the low-speed stability of a cylinder is not as good as that of a hydraulic cylinder. 2. Although in many applications the output force of a cylinder can meet the working requirements, its output force is smaller than that of a hydraulic cylinder. 3. There is considerable exhaust noise. Next, let's study several typical control circuits of pneumatic systems. 1. Directional control circuit. As shown in the diagram, Figure A is the direct control reversing circuit of a single-acting cylinder using one directional valve to control the cylinder. Figure B is the indirect control reversing circuit of a single-acting cylinder using two directional valves to control the cylinder. 2. Pressure control circuit. By using a pressure regulator 1 to adjust the air circuit pressure, the thrust of the cylinder rod can be adjusted. 3. Speed control circuit. In this pneumatic circuit, a throttle valve can be used to adjust the speed of the compressed air entering the cylinder, thereby controlling the moving speed of a cylinder rod. Thank you for your attention. See you in the next class.